Hey Venkat, Venkat, you are on mute. Can you hear me?
Suresh, can you hear me?
Yes, Venkat. Yes. All right, let's get started.
So I have 30 minutes, right?
Yeah, you have 30 minutes, Venkat.
Okay. So do we wait for people to join or we are good to go?
No, we are good, Venkat. So I'll just give a quick introduction about you.
Sure.
So it's an honor to have Venkatesh Iyengar with us, and he comes with a career spanning across 2 decades in the quality engineering sector. He has first-hand experience navigating the ever-evolving technology landscape and its profound effect on enterprises. So he enjoys continuous learning, simplifying messages for stakeholders, and exploring new technology and business ideas. Venki also holds a patent in QV maturity model design, and outside of his professional life, he enjoys long hikes, long distance runs, and tennis. So, Venki, we are really excited to hearing about reimaging quality engineering in the era. Over to you.
Thank you, Suresh. And a very good day to everybody who has joined. Like Suresh mentioned, my job is really to look at the wide variety of customers that we have across different geographies, different industry segments, and look at the best practices and bring together a set of practices that can enable the customers in their transformation journey. So now I'm going to share some of the observations and things that we are looking at in from a different practical lens perspective. And there are two topics that we will cover, and I think you have heard quite a few of our speakers in the morning session. Uh, Rest of the day, you will hear continuously about how do we leverage AI for quality engineering and the quality engineering for AI. And so I'm not going to belabor about defining what these two are, but let me set us a little bit of context from where we are seeing how things are evolving, right? The What I would call them as quality engineering 1.0, 2.0, and 3.0. Quality 1.0 was a pre-cloud era where we used to do a lot of independent validation, mostly manual testing. Release cycles used to be, even for a small project, would used to be upwards of 3+ months. And then we have been in this quality 2.0 era for some time. Most customers have matured into this quality 2.0, where the applications are either cloud native or becoming cloud native. Customers have moved into maybe a product centric model. We have a integrated validation, right? Customers integrate the testing along with the product development, where you could see on an average at an industry level it's 50% automated or so. There used to be a big focus on regression, focus on business. The release cycles came down as a net result because of all the automation and everything else. From a business benefit perspective, the release cycle came down to 2 to 3 weeks. But we are entering into a very new world and a new era. We call it as QE, Quality Engineering 3.0, where the systems are becoming distributed, um, and they're connected and they're becoming intelligent. What do I mean by that? See, majority of the applications are not necessarily going to be sitting in one place. They are going to probably move into a blockchain kind of a system potentially in the coming days. They're going to be obviously be connected because they're already cloud native. They are interconnected with each other. And most importantly, the last element, which is the intelligent systems. That means they're constantly learning, and you cannot really predict what the behavior is going to be in every instance. So you need to be, and so you need earlier the automation was a choice. because if the applications are deterministic and if it is working well and you have not broken any piece of the code, then there is no real need to automate those. So automation was a choice. But I think we are entering into a space where automation and the way we test has to be 100% automated. I don't think we have a choice. The context is you find an issue, you need to release a defect or a fix immediately, and the kind of experience that from a quality engineering perspective that we need to have also is going to evolve dramatically. So in this context, if you have to automate 90% plus or 100% of the work that we do, there is no option but us to be far more productive. And therefore the role of AI in the kind of quality engineering that we do, even in the regular probably deterministic system applications, is going to be huge. So this is where we think we are going to go into. And so let's look at what are the use cases that we are observing in the usage of AI for quality engineering in the current set of applications. So that will give us a good sense for what's real right now happening. Then we will also look at what's the implementation view. How is it getting actually implemented, and how are the customers looking at the various parameters around the return on investment. So if you look at from what we are observing, there are three broad categories of use cases and the implementation views, right? The one where the most customers have already sort of made it as part of the software testing life cycle is on the left hand side, low hanging fruits. It's already done. We see a lot of return on investment and it is already there. The second one is where I think right now where we are right today, implementing for different customers in different forms and shapes, which is we call it as enhanced Gen AI capabilities. And the last one is the emerging area, where it is still early days. It is beginning to happen. Probably it will take another year or year and a half or two for it to mature, and some of these to move into the second pillar. So if you look at the low-hanging fruits, we have used either the Gen AI or the regular AI capabilities for doing the user story quality analysis, test case authoring from the requirement documents, or automated script generation from the manual test cases, and then performance analytics with Gen AI. Gen AI in SAP testing has been a very popular use case because it's a well packaged applications, and the T codes are well defined. And then you leverage AI pair programming, for example, as part of the development. You don't need large learning on the go or engagement specific learning. So that's where you have a lot of these low hanging fruits that are fairly well mature in terms of the implementation. And then the second pillar that you are seeing, this is where a lot of the
Venkat, sorry to cut you.
sure.
We are not able to see any. I think we are still on slide one. Yeah,
Oh,
we can.
okay. Hold on. Now, are you able to see it, Suresh?
Yes, we are on slide six. Yes, perfect.
Okay. Yeah. So the automated script conversion. Many customers are today looking at, yeah, hey, I have an outdated UFT script. How do I convert it into Selenium? Or I have some SQL scripts. How do I convert? So this is where you easily can train using LLM or any other capabilities that we have, and help in the script conversion. And similarly, a lot of customers actually postponed their mainframe modernization or modernization efforts. And so how do we leverage the uh, code conversion capability from the from the existing code? How do you reverse engineer it into English language? Come out with the story points, and then create use cases and test cases to make sure that the new code that you build is working correctly. And similarly, now we are beginning to see the usage of generative AI for test data management, even the test environment management, with different reports being generated. And then we are looking at usage of AI analytics, right? For example, there are many use cases, and I'll double click on a couple of these just to give some samples. Usage of generative AI for defect classification, defect engineering. A lot of these things are getting benefited from the new AI, generative AI capability. And security scripting, every type of testing is getting redefined with the AI first approach, each of these capabilities. And then finally, moving into the emerging area, agentic AI is becoming a new approach that we are adopting, so that it is not that individual tools you have to implement. You can look at it from an end-to-end perspective. You can look at how the entire ecosystem, right from, let's say, if it is at the Jira stage, there is a user story, taking it all the way from analysis of the quality all the way to generating the test cases, and making sure that it can even be executed, right? All of that agentic AI will do. And similarly, I think the previous speaker was also talking about it, the multimodal capabilities is going to come in. So instead of people trying to even write a prompt, you can even speak, or it can some of the visual capabilities can even be used to test the systems that require camera. All of these, including the knowledge management with small language models, just for testing, right? So there will be evolution of creation of small language model for testing, so you don't have to really learn specific to a testing type of activity. And then you will build domain based, for example, energy, industry specific domain models, and you will build test case repository. Therefore, it will know how to really develop the test cases you at a better quality. And then finally, creating QE fine-tuned models and log analytics from the production logs. How do you analyze the data and build it for automatically the test cases for the regression, right? All of these capabilities are going to what we see as the evolution. And so if you look at one of them, Suresh, can you confirm that you are able to see the next slide?
Yes, sir. Be able to see it. Yes.
Yeah. So if you look at one use case, how the AI pair programming in quality engineering tasks, today the pair programmers that you see in the market, GitHub Copilot or Amazon Q or any of these are fairly popular, and a lot of our customers, enterprises are using this. And many of these use cases, right, the kind of use cases that customers are using the pair programming are these, BDD file generation or script conversion, many of these. And you can use the Selenium TestNG to playwright conversion, right, using the GitHub. So some of these capabilities are already pre-built into some of these tools. You cannot teach them right now, but whatever they have been already pre-taught, that is what we can use. And so what can we do to really even further accelerate this? We can build reusable prompt libraries, how to make sure that they generate fairly accurate outputs is something that we can do. So this is one example of how we are leveraging AI in terms of making sure that it can help in accelerating the test activities. And similarly, if you go to the next example of QE analytics, traditional versus generative AI, defect classification, we used to use the traditional AI. It has been replaced with the generative AI. In what is different? There are defect engineering, defect classification. All of that is done through various LLM training methods that you use on the historical data, and making sure that you can provide a lot more information about all of these capabilities. And similarly, the knowledge management, self-service, QE, various activities that where we were using the traditional AI has been replaced with generative AI. So all of these will help in accelerating our. And similarly, one more question that I saw in the previous: what is the role of the traditional testing tools, and are they getting replaced with generative AI? What we are observing is some, obviously, tools probably will get outdated very soon, but many will survive. But what we are, at least today, we are observing is the existing tools are getting augmented with the AI. For example, synthetic test data generation. Customers are adding to the existing tools that they have different type of additional capabilities. Similarly, generating the test scenarios from process flow diagrams, maybe from Signavio or Celonis. How do you add? So these are the areas where you're not going to replace Signavio, but you will add the generative AI capability on top of that to really make sure that you are able to make the best use of the existing tools, but accelerate it fast, farther. So what is the bigger impact in my mind? If you ask, it's potentially the number of licenses that they require for each of the existing industry tools may go down, depending on the customer landscape, right? And similarly, depending on the way they license it or the price it, that may have a modification. But will they actually go down? There are multiple views on that, for the simple reason that customers are unlikely to reduce the IT spend. So therefore, the number of programs that we may have to deliver will increase, and therefore, overall, the tools requirement will continue to be there. And it is very important for us to really complement these tools with AI capabilities. Otherwise, they will likely not survive for too long. So that's about how we do the QE for AI inside the QE landscape. Now let's look at the next one. Where is the value creation, right? If you look at from an ROI perspective, you have to capture some of the data points around the requirement quality, the impact analysis, various efforts that you spend today. But then, in the AI world, you have to also capture the cost of setup, or what are the services that you have to bring in, what is the cost of human that has to be in the loop, what is the overall cost, and that will give you a sense for what is the to be cost and what is the savings that you will achieve. And more importantly, I think there is a time value for money that you have to capture. For example, if you are able to deliver, instead of a test release cycle taking 6 weeks, if you're able to do it in 6 days, the time that you have saved will impact the business significantly. You will be able to deliver more number of features. So there is a much greater value that will come because of the time reduction that you will, more than the direct cost reduction. So this is the way we have approached different customers to really drive why they should really invest in maybe one-time cost in implementing the various AI use cases. And now I will take a few minutes to explain how the world of quality engineering for AI is evolving. We will briefly cover what are the challenges to expect. You have heard of these in many sessions, and what is the approach that we are looking at from an AI assurance perspective, and what are the solutions that you can implement, and what are the startups in this space, and what are the metrics to focus on. So these are the 5 elements that we will focus on. I know we have a very limited time today, but I will be happy to take more questions. So, we were within the company, we were implementing various generative AI based solutions. And when we were doing the testing of these, we came up with number of issues that we found with that application. And so then, we sort of classified them into different types of issues, whether it is functional, whether it is related to the base LLM that we used, or was it related to performance, and etc. Right? So then, that is when we created this framework to really understand where are the potential failure points. In my mind, the picture on the right-hand side is really a good representation of all the potential failure points that you can anticipate in a agentic AI-based system. If you look at tool usage, let's start from the tool usage. Whether in a AI-infused application world, when a user asks a question, does it really invoke the right set of applications? Does it invoke the right set of tools to really do the function that is required? Does the responsiveness each of these tools is efficient enough? And do these tools provide accurate response every time it is? And how do you test for each of them? These are the potential failure points that you have to observe. Similarly, you look at the memory usage. Whether if you run it continuously, whether there is going to be a data storage, and whether there is impact on the retrieval part of the memory. How good is it? Whether you have enough GPU all of that, you have to think about. And then similarly, you go through each of these parameters, elements, reasoning, is it relevant? Is it giving, is there if somebody asks a follow-up question, is it really giving the right response? And then agent decision making, in my mind, this is one of the key parameters, right? We have seen several times the way AI systems behave is based on the goal that has been set for the agent. For example, if in YouTube, the goal is set as maximize user interaction, and that becomes the goal for the AI agent. Now, in order to make the number of interactions greater, whatever that will drive the number of interactions greater is the one that will get shown to the users, even though it may not be the best content for the platform. For example, some violence or some nudity, all of these kind of factors can drive the user views on the platform. And therefore, you have to make sure that the alignment with the goal is not necessarily the only driving factor, and the goal may have to be redefined properly. And how do you make sure that from a quality engineering perspective, we are looking at what is the goal of the AI agent, and is that goal defined correctly, and what are the pitfalls of that particular goal? So we have to look at that. And similarly, orchestration, different aspects of the subtask accuracy, subtask, all of that, when you're orchestrating different element, how do you make sure that it is accurate, and whether it is going above and beyond what it has been asked? All of that has to be done. And finally, red teaming. We know that there is so much of fake videos and fake voice messaging that is going on. How do you find out the toxicity? You have to really make sure that there is red teaming along sitting with the development team that is building this AI system to really bring out the various issues that are vulnerabilities that are there with and it costs more to build a vulnerable AI fake video than to really find it. So if we plan it, we can find it. And so it is much easier. There are tools available today. And similarly, going into each of these elements, right? For the lack of time, I will just give you these high level parameters. And then if you look at what we have done is we have taken a very holistic approach, and we call this as a 4-pillared approach. There are 4 dimensions to the AI assurance. One is the business assurance, where we talked about alignment with the business goals, satisfy business requirements, etc. The second one is the red teaming, looking at the adversarial impacts of different AI systems and how to test them. The third one is responsible AI, where we are ensuring that it is operating ethically and adhering to the regulatory guidelines and accountability and all of that. And then finally, from a benchmarking of the agent itself, from various performance perspective, external standards perspective. And so each of these require one, what you need to test, and then how to test. So, we have done the detailed due diligence on how to do each of these activities. As you can see, business assurance, alignment with these are the factors that you have to test for. But how do you test? Again, test data becomes a major topic. And so, we have built a platform that takes care of all of these activities, right? Whether it is the user interface or functional testing, hallucination checks, and all of that. And then, when some of the multiple external LLMs have to be integrated, then you can also use the RPA to really bring together all the activities that you need to do. So, but you need a business assurance. And similarly, you need agent benchmarking. What all do you take care of it? Transparency, accountability, component level testing, all of that has to be done. Again, there are tools in the market as well as you can see, Arise AI, Agent as a Judge. All of these tools are available. And for each of these subtopics, there is a very clear methodology of how you should do the testing, what tools can be used, what are the metrics to use. And so that is the second type of testing. The third one is AI red teaming. Here you simulate attacks, you find out various ways, somebody can generate a fake video or any of the ways it can fail. So you can come up with various tools. Again, there are industry tools plus our own tools. So which does the the check on from a vulnerability perspective. And the last one is responsible AI. Here again, you look at various activities, whether it is bias or fairness, explainability audits. Again, there is a industry tool called AI Fairness. You can use that, or Infosys, we have built a platform. In our platform, this is integrated into the capability. So that we give you some sort of a view, and so I'll just quickly summarize the there are these startups. Several startups have evolved in this particular space, and you can go look up and search for some of these, and they, each of them have been really building unique capabilities within a particular space of the kind of AI assurance that you need to do. And you may have to bring multiple of them, or we can orchestrate them through one platform. That is what we are doing, including building our own capabilities. So this is one interesting space. And the second thing is, in each type of testing, you need to also understand the type of testing that you need to do. But more importantly, when we say step level testing, how do you measure it? What are the different frameworks that you should use? And so this is the second category of information that you need to have in your mind while you're embarking on the journey towards testing AI applications. So with that, I know I'm towards the end of the time, and I'm going to pause here. Thank you so much for your attention and time. Suresh, over to you.
Yeah, so we have 2 minutes, so maybe I think a couple of questions we can focus on. So since you touched upon metrics, right? So what are the key metrics that any organization should track to measure the ROI of integrating AI into quality engineering?
See, the number one is the test life cycle reduction. The ability to reduce the amount of time that a release takes is, in my mind, the biggest metric one should start with. And if they are able to bring down that time over a period of time, you can really put the time value for money. You should never be delayed to go into production because of that amount of time it takes to test. So that's in my mind the number one metric. And after that, obviously there are several efficiency metrics, the amount of time that you take for testing, or effort that you take for testing. Those are the metrics that I would say is obviously we are all from quality engineering. It goes without saying that the quality is number one primary parameter. You should not compromise on the quality, obviously.
All right. Yeah, I think we just have very few seconds left, so I think we'll not be able to take more questions. But I think it was a great session, Venkatesh. I think it was great having you, and we had a very insightful discussion. Thank you. Thanks for your time.
Thanks, Suresh. Thanks, everybody.
Thank you.